You can ask if I've got a question. Okay. Now, let's talk about this question which came in 20, this is 2020, 2020, 2019, somewhere there. Now, this question is coming from the introduction of Newton's laws of motion. So, understanding the question is one of the most important thing in physics, like I've been saying always. A horizontal force of 140 Newton is needed to pull a 60 kg box across a horizontal floor at a constant speed. What is the coefficient of friction between the floor and the box? One thing should come in your mind right now is when you're talking about the constant speed, then what is the acceleration? Zero. Meaning that if the acceleration is zero, what is the net force? It's also zero because the net force is mass times acceleration. Acceleration is zero, net force is zero. Now, the first thing is come up with a free body diagram. Okay? In the morning, we're talking about a free body. I explained what a free body diagram is. Okay? So a free body diagram is just a simple diagram which is going to make yourself to understand what you're doing. So we have been told that it is in the horizontal. We have got a box. Then this box is 60 kgs. And a force of what? We are using a force of 140 Newton to push it, to pull it. Okay? Meaning that if there is friction, friction is opposing the motion. Initially, sometimes you might think to say the way I've written this diagram is more like we are pushing and not pulling also. But it's okay. It's fine. You can leave it like that. It's okay. So there is friction force here, which is opposing the motion. Then you come here. The question is find the coefficient of friction. The summation of all the forces in x direction. In this case, this object was moving in x direction. We're not interested in the forces in y direction because it is horizontally, meaning that the forces in y direction they are cancelling out. There we go. So the forces here, we have got the applied force minus the friction force. The applied force, in this case, we're saying that the net force is zero. You replace this with a zero. The applied force is 140. The friction force is mu times the normal force. But what is normal force? We have got mg here, the normal force here. So in this case, the normal force is equal to mg. I believe we know this, right? So I'll say, shift this to the other side. It's the same as saying mu times Fn is equal to 140. Fn is mg. Here should be equal to 140. Divide both sides by mg, even here by mg. So these will go. The mu will be equal to 140 divided by m is 60 times 9.8. Mu will always be less than 1. The answer which we are supposed to find here should be less than 1. So I'll say 140 divided by 160 60 times 9.8. I'm getting 0.34 or 0.24. Confirm.
Yes, that's correct.
Okay. Anyone who has got a question there? Now here, what I'll do is, when I see such kind of question, I'll try by all means I explain even other concept. The same question, let's say it was being pulled at an angle, and you're going to see this question 20. That should be what? Is it 2020? This question came. It was question should be 5. Yeah, question 5. So let's say it was being pulled at an angle. I'm going to give you tools now. So if it was, there's a reason why I was talking about pulling and pushing. These two things are different, right? What's the difference between pushing and pulling?
I think pulling
Hmm.
is when you are getting something close to you, but when you are pushing it, meaning it will leave your presence go other direction.
Mm, okay. Okay. Yeah. Okay. Explanation is okay. Pulling is like you are drawing it closer to you and then pushing away from you. So now what is happening here is this. For example, this question it was talking about pulling. So I'm going to use pulling. Then I'm going to give you another scenario of pushing. Okay. So let's say you are pulling this using a rope, and you are pulling it at an angle of what? 30 degrees. Okay. So you know that this is going to be, when you are pulling, meaning you are using a rope, which is the tension force in that case. So we can call that as tension force or just force. Is fine. No one is going to penalize you. Let's say this force is 140, and then you have been told that there is a friction. Okay. And the net force is 0, like the way this question is, and the mass is the same, 60 kgs, like that. Let's find the coefficient friction. Have you seen what I've done here? You are pulling it, but now it is at an angle. You are not pushing, you are pulling. Now when you are pulling, the arrow you draw a line from here, then there you need to put an arrow showing where you are pulling it, meaning that vector, you have got x component and y component. I want you to see what's happening here. Definitely this is going to be your tx, this is going to be your ty. So in this case, this object, this force, you can clearly see that when you have got a force in this direction, it is moving in both x and y direction. Then you are going to say, since this object is moving in x direction, you say the summation of forces in x direction, we have got the tx, okay, minus the fk. The fk is the friction force. The normal force, this is going to be replaced by 0 because it is at constant speed. So 0 is equal to tx minus this tx, according to Sokatowa, is the same as t cos theta, right? Let's do it from here. Is t cos theta, ty is t sin theta, like that. So now, meaning that here, this is going to be replaced by 0. This is going to be t cos theta. Then this is now mu times the normal force. But what is the normal force in this case? If it was applied at an angle, the normal force in that case is not mg. No. So here there is normal force. There is weight force here, which is mg. Again, there is normal force here. So I will say the summation of forces in y-axis, for me to make Fn as the subject of formula. The forces which are pointing upward, I've got Fn, and also Ty is pointing upward. I need to add that T1. ty, then minus mg. Make Fn as a subject of formula. This is 0, so it's going to be Fn. This is t sine theta minus mg. Okay, so I can shift these two guys to the other side. So it's going to be mg minus t sine theta is equal to Fn. Meaning that this mg minus t sine theta is the one I'm going to replace it there. Does that make sense? Then you make this as a subject of formula. Or what you can do, you can just get it from here. You leave it first there, then you get it from here to say, if you shift everything here to the other side, it's going to give you mu mg, or mu times Fn, sorry. Mu Fn is equal to t cos theta. So you know that this is going to be replaced by everything here, which is the same as dividing it by Fn, dividing it by Fn. Meaning that mu will be equal to t cos theta divided by mg minus t sine theta. Like that. Meaning that will be the formula now for finding the what? The mu value. Does that make sense?
Yes, sir.
Another issue. What if this thing is being pushed and not pulled? It's going to be different now. I want you to see. When we're talking about pushing the mu value, the formula is going to be different. So if they're asking about pushing, meaning you are pushing this there at an angle. Okay? Meaning that this one now is coming from there, going there. So you have got still ty and tx. So you have got mg, then the normal force is there. You do the same, the friction force is opposing, so it will be in this direction. Okay, that's the friction force. So you're saying the summation of all the forces in x direction will be equal to, we have got tx in x minus fg or fk, which is the friction. 0 is equal to, according to Sokotoa, this is still going to be t cos theta minus mu fn. But what is fn in this case? I'll do the same. But in this case, since this vector is going in this direction, meaning that the y is pointing downward, that is when you are pushing. When you are pushing, the y is going to be pointing downward. When you are pulling, the y value will be pointing upward. That's a difference. Then make fn as a subject of formula. Come and plug in here. Make mu as a subject of formula there. Then that will be your mu value. Have I made myself clear?
Yes, sir.
I can combine this with this question. This question came in 2017, 2021, 2022 final exam. They just repeated. The speed limit along a certain road is 80 kilometers per hour. To stop at a junction, the driver applied excessive force on the brake and skidded for 55 meters before stopping. The coefficient of kinetic friction, which is mu k, between the tires and the road is 0.75. Determine if the driver exceeded the speed limit. If we have got any, or do we have anyone who can solve this question? Or if you have understood the question, let me know. In our calculation, are we going to use 80 kilometers per hour?
No, we are going to convert it.
Oh, you are not answering my question. My question is, in our calculations, are we going to use 80 kilometers per hour? Why? Why? Okay, that's perfect. So 80 kilometers is our speed limit. So the answer we're going to find, the question is determine if the driver exceeded the speed limit. If the answer is going to be greater than 80 kilometers per hour, then the driver exceeded the limit. Then if the answer is going to be less than 80 kilometers per hour, then the driver did not exceed the limit. But anyway, let's see. For this accident to happen, meaning maybe he exceeded the limit, we don't know, but let's see. So let's do some simple calculations. So if this happened to be our road, this road, the distance is 55. Initially, when the car is moving from this point, we call it initial speed. So the car will be moving with a certain initial speed. The moment this car is going to skid at this point, do you think after the accident, do you think it's going to... Oh, they are saying that the driver applied excessive force on the brakes and skidded for 55 meters before stopping. Do you think that when the car was stopping, did it have velocity now? What would be the final velocity when it stopped? Zero. Anyway, it's zero because it's not moving. It has stopped. When an object is decelerating, so from let me call this point A and this point B. When an object is coming from point A to point B, was it decelerating or accelerating?
Repeat the question, sir.
When this car was moving from point A to B, was it accelerating or decelerating? Exactly, because it was coming to stop, it was coming to, yes, it was coming to stop, so it was definitely decelerating. What comes in your mind? What would be the value of, what would be the sign for acceleration which you are going to find? Negative, definitely. Exactly. Now, what I want you to understand here is this. The first thing we need first to find, they want you to find the initial speed. You know the final speed. Okay? Which formula can we use? Under linear motion, I'm going to give you a hint. The only formula which can work here, since we don't have time, is the third equation, where we say v final squared is equal to v initial squared plus 2ad. But in this case, we want to find the initial speed. Okay? We can clearly see, guys, that we have the final speed as 0. We have the d, but we don't have the initial velocity, and we don't have the acceleration. So if this is the car here, okay, what do you think? What was the force which was acting on this car? There is only one force which was acting on this car as it was decelerating. What force is that? Exactly. Because we're talking about friction force, there is no any other force which we are talking about right now. From the question here, we are only interested in friction force, meaning the only force which was acting is the friction force. And friction force, it was opposing the motion. In this case, going to be directed there. So I'll say, to find the acceleration, I'll say the summation of the forces in x direction. I have got the friction force. But is this friction force, it is in the negative x-axis, so I'm going to say negative fk. This is going to be replaced by ma to be equal to negative mu times mg, because normal force is mg. I can definitely cancel m, and I've not been given m. Acceleration will be equal to negative mu times g, and that's the reason why we said it is decelerating. Acceleration is going to be negative. This is where it's coming from, guys. So a will be equal to the mu value have been given 0.75 times 9.8. Those having calculators, what will be our acceleration? Isn't it 0.3? No, not 0.3. 0.75 times 9.8. 7.35. Confirm.
Sorry.
It's correct. The next thing which we are going to do, yes please, you can ask. If you have got a question, you can ask. So the final velocity squared is equal to, or I know the final velocity. Yes, you can ask if you have got a question. It's 0. The initial I don't know. The acceleration is negative 7.35. The distance we have been told is 55. Shift this to the other side. It's going to be negative v squared is equal to, if we do the math there, it's going to be negative 7.35 times 2 times 55. Okay, I'm getting negative 808.5. Negative and negative can go, so we can square root then. So v initial will be equal to, so what will be the square root of 808.5? I'm getting 28.43 meters per second. We can't conclude right now that it exceeded the speed limit or not, because this is in meters, that is in kilometers. So you choose either to change this to meters per second or to change this to kilometers per second. Which one will be easy for us?
Change a kilometer to seconds.
Okay, let's change 80 kilometers per 1 hour will be equal to, in 1 kilometer I've got 1,000 meters. In 1 hour I've got 3,600 seconds. So kilometer and kilometer can go, hour and hour can go. These 20 can go, these 20 can go. Meaning I've remained with 80 times 10, which is 800, divided by 36. I'm getting 22. So meaning that 80 kilometers per hour is the same as 22.22 meters per second. What will be your conclusion? Did the driver exceed the speed limit or not? Yes, please.
He exceeded the speed limit.
Reason.
Speed comparing to it of that of a speed limit. About 6.5, if not mistaken.
Okay, that's your reasoning. Others, what can be your reason? Why do you think the driver exceeded the speed limit? Reason, simple reason here. We have got the answers. Guys, yes. Mm-hmm. What's the reason?
So we've been given the speed, the speed because the speed limit that was given there when we converted is 22. Then his initial that we found is 28. So meaning he went beyond the limit that was given.
Mm, that's all. Okay. It's just to say, in simple terms, we can say the driver exceeded the speed limit because the initial speed is greater than the speed limit. That's all. As simple as that. Sometimes you can just say 28. The driver exceeded the speed limit because 28.43 meters per second is greater than 22.22 meters per second. Simple. The driver exceeded the speed limit because 28.43 meters per second is greater than 22.22 meters per second. It's okay. You can write your own in your own English, but still they'll mark it. So that is the general idea, that those two questions, they have given us a general idea behind Newton's laws of motion. And then there's this one. This is more like a contact force, but again there's this one. What else? Okay, these are the ones I prepared, but this, can't we just do this? Okay, let's first do this one. This one is we're supposed to do it after before. Okay, let's do this one, then we go to that one. This is more like an incline. So a skier starts from rest and slide 50 meters down a slope that makes an angle of 40 degrees. This is supposed to be 40 degrees. There is no 400 degrees. 40 degrees. These are guys who are making Dafroid. They are failing to edit simple things here. So this is 40 degrees and not 400. Okay? With the horizontal. She then continues sliding on the level snow. If the coefficient of kinetic friction between the skies and snow is 0.11 and the air resistance is neglected, what is the speed of the skier at the foot of the slope? But two, how far away from the foot of the slope does she comes to rest? Okay. Who understands this question before we solve? Who understands this question? Anyone who can try.
I think in this case you're supposed to draw an inclined plane.
Okay, here is my inclined plane, sir. What's next?
Okay, drawing an after drawing an it was coming down.
So now here, she then continues sliding on a level snow. What does it mean?
Meaning after reaching the ground
Mhm.
is continue.
Yeah, so she continues up to, we don't know, maybe somewhere there. Not so. Now,
Yes.
sometimes understanding the question is one of the most important. So now we are saying the question from this point here, if you read the question from here all the way to here, they are not mentioning anything about the snow. She then continues sliding on the level snow. Get me right there. Then part A, if the coefficient of kinetic friction between the skies and the snow is 0.1 and air resistance is neglected, what is the speed of this car at the foot of the slope? So now, as this car was coming from this point here, sliding down, reaching at this point, it started with the initial velocity was 0. So what was the final velocity at this point? That's the question. So we need first to find the acceleration also. You get my point, right? So finding the acceleration, this is one of the things we are from talking about. So one thing we have to remember to find the acceleration, what force do you think was making this sky to come down? I explained this. So what would be the summation of the forces in this case? And I mentioned to say they are not going to tell you the force in that case. So what force makes this sky to slide down?
FG.
Fg. Do we have friction?
Yes, sir.
Okay, so what are we going to say?
Since friction is opposing, so it will be minus friction force.
Minus friction force. Now, another person might think to say, why can't we say, because they are saying that if the coefficient of kinetic friction between the skies and snow, and looking at it, was incline also part of the snow? Hmm? No, I'm just asking. We are solving, and then I've just posed the question. Hmm?
What's your question? You're saying that was the incline part of the snow?
Yes. Why are we adding friction force to the part of the incline part only, where we are trying to find the acceleration, and then we come back, we find the velocity? Don't you think that the friction was only from this part all the way to that part? Because the question is saying she then continues riding on the level snow, meaning that the snow is this one. So I'm asking you, why are we adding the friction force, the part of the incline? No, it's just a question. I want you just to answer. I'm not saying it's wrong. No. Hmm? What are your suggestions, guys? Your suggestions are welcome. What are we saying?
Okay, so on this one,
Hmm.
without a friction force to be
Hmm.
applied,
Hmm.
this car can move with a high speed going down there. So
Hmm.
with the help of a friction force, it reduces the speed of this sky. I think that's the suggestion from your side.
Okay. Who else is going to just Nori? What are you saying about Newton's laws of motion? This is your favorite topic.
So as for me, what I just know is that the fact the sky was moving from a higher surface to a lower surface, there was obviously friction force as much as there was gravity pulling pulling the scar downwards.
But do you know that the car can also go down without friction, right? Okay. Anyway, we are going to discuss about this later. Anyway, let's just put it. Okay. It's all right, even if you don't know the explanation, but it's fine. No one is going to ask you about the explanation. I was just trying to see. Okay. Um. Initially, the way it is. It's like even the incline itself here, it was snow. Everything here from there all the way down there until you come down. So even here, when we're calculating how far, we are going to include the friction force. You get my point, right? So say the mass times A will be equal to Fg. We said is what? We have talked about this already. Fg is what? Under incline. hmm
mg
Sine theta minus what is this is going to be mu times the normal force. The normal force is mg cos theta, not so.
cos
So since we have not been given the mass, we can cancel the mass everywhere. Here we have got mass. Our acceleration will be equal to, this is the same as the formula I was telling you. I can factor out g sine theta minus mu, then g cos theta. I can now plug in the values. A will be equal to g is 9.8, sine the angle is 40 degrees, minus mu is 0.1 times 9.8, then cos theta. You need to be careful when punching on your calculator. You first need to say 0.1 times 9.8, which is 8.98. So you say 8.98 divided by is 0.1 times 9.8 is 0.99, 0.98. Those having calculators, Kairi. So 0.98, you need to do it cos, or you can say sine 40 minus 0.98 cos 40. What are you getting? What are you getting? Those having calculators, what are you getting? I'm going to show you something. I want you to observe something. What are you getting? You are supposed to get a negative, right? Those calculating, what are you getting, guys? Nori, what are you getting?
So I'm still calculating, but I can't really see what you've written after 0.1.
0.1 times 9.8.
So,
Mhm.
I found without multiplying with the 9.8,
Yes, yes.
I found negative. The acceleration
Uh-huh.
will be negative 1 point 1.1, yeah, negative 1.1.
You have found acceleration as negative 1 point,
1.1.
negative 1.1. Okay. So now I want to tell you something, guys. Um, what comes in your mind? We are trying to find, the first question is, what is the speed of this car at the bottom? The speed has to be positive. Okay, so definitely I wanted to show you something. Definitely physics sometimes it can, like in this case I knew to say, the reason why I told you to say okay, let's solve, you're going to see once I include the friction force here, definitely the acceleration is going to be negative, and we are going to find the velocity there to be negative, which is not possible. It's not true. That's why I was interested from this point here, from this point here, because the reason what you have given me is exact as those guys who gave me, they gave me the same reason in 2022, that we should include the friction force. Because so this question, initially the people who were making this question, the first part of the question, this one was not necessary. It was just confusing people. This was supposed to be added. This part here was supposed to be added when they were asking about the second question, because the friction force will only apply the second question. Because this no which we're talking about here, they are saying that when they're talking about from this point here all the way to this point, they're not mentioning anything about the snow. So the snow is just there after it reached down the incline. That's why they are saying she then continues sliding on the level snow, meaning that the incline was not part of the snow. So they're saying that the friction force between the scar and the snow is, so this is just the friction, this one is just part of this part here when it was coming down only. Have I made myself clear there? Yes. Have I made myself clear? The
Yes, sir. Yes, sir.
the acceleration can only be negative from this point all the way to there. That's when it was what? Decreasing. So when finding the velocity here, if you've got question you can just ask because of time.
My question is, since Newton's laws of motion, if you use work energy theory, can you be penalized?
No, no, you can't be penalized. Like in this case, you can't be penalized because they have not mentioned. You can mute your mic. Mute your mic. You cannot be penalized because they have not mentioned which method you are supposed to use. But in most cases, they are going to tell you to say use Newton's laws of motion or use work energy theorem. But in this case, you can use any. It's okay. Work energy and power can even be very simple and easy. Not so.
Yes.
Do you want us to use that?
Yes, I think it would be easier. But we can also use the one we wanted to use so that we just know in case they'll tell us to use the Newton's laws of motion.
Okay. So, okay, what I'm going to do is I'm going to use Newton's laws of motion. You go and try using work energy and power, and then you compare the answers. Okay.
Alright.
So I'll say I'm going to say the summation of the forces. I want to find the acceleration. The summation of the forces is going to be Fg. The only force that makes the car to move down is Fg. So this will be M A is equal to M G sine theta. Let's cancel M. A will be equal to A G sine theta, which is 9.8 sine 40. So what will be the answer? 9.8 sine 40. 6.3. Okay, it's making sense. 6.3 is my acceleration. Now let's find the velocity. V final squared is equal to V initial squared plus 2AD. The V final squared is the one we're trying to find. The initial it started from rest is 0. Acceleration 6.3. D is 50. V final squared will be equal to 2 times 6.3 times 15. What are we getting? 630. 630. Now I get the square root. V final will be equal to 25.1. That's the answer for part 1. Part 2. How far away from the foot? Now they're asking about the distance. So this is going to act as my initial velocity now. The final velocity is going to be 0 because it ended there. So my initial velocity now is going to act as 25.1 meters per second. And I want to find how far. Okay? So first I need to find the acceleration, because the only force which was acting in that case, it was decelerating. So the only force acting in that direction, in that case, it was what? The friction force. It's the same as the question we are from solving. It's going to be the friction force. It was opposing the motion in that case. That's the only force which is there. Then I'm going to say MA will be equal to mu times the normal force. Normal force in this case is just on the level ground, so it's mg. Cancel m, we don't have m. A will be equal to mu times g. The mu is 0.1 times 9.8, and d is going to be negative 0.98 meters per second squared. Again, you go back to our formula, which is this. You plug in all the values, make d as a subject of formula, find the d, and definitely is going to be positive. Without wasting much of our time, let's plug in the values. So the final now will be 0. The initial is going to be 25.1 plus 2 acceleration negative 0.98 times d, which we don't know, is the one we're trying to find. Shift this to the other side. This has to be squared. It's negative 25.1 squared is equal to, if I do 2 times 0.89, should be 1.96. Negative 1.96 times d divided by negative 1.96, negative 1.96. So d will be equal to negative and negative will cancel. So I have 25.1 squared divided by 1.96. 1.96. So 331 meters. 0.4 meters. As simple as that. Unless you have got questions.